Okay, so to get started on this one, write the domain of each function in the interval notation. So we have two main restrictions when it comes to domains of functions. Number one, the inside of a square root, this part of it, must be bigger than 0 or equal to. We can't have a negative inside of a square root. If so, we have an imaginary stuff going on and we just don't want to deal with that. The other thing is, the bottom of a fraction, I'll put point to the bottom part, cannot be 0. It can be anything but 0. So, going to part A, we don't have any square roots here, so the only thing we need to worry about is the bottom of the fraction can't be 0. So say 3x minus 7 cannot be 0. I'll essentially find out the one value that it can't equal, and we can make our domain avoiding that value. So I'll add the 7, can't be 7, x cannot be 7 over 3. So our domain for 23 is going to be minus infinity to 7 over 3. We're going to do a union 7 over 3 to infinity, where we're going all the way up to 7 over 3. We're going to skip that, and then we're going to go from 7 over 3 on. Everything except for that. For part B, we have x minus 6 inside of square root. So I'll say x minus 6, the inside, just kind of has to be bigger than or equal to 0. Well, I can just solve for x here. So that means x must be bigger than or equal to 6. So we're going to have a bracket 6 to infinity. Every number that's bigger than 6 works there. For the C, we don't have a square root, and we don't have anything like a denominator for the fraction. So it's going to be minus infinity, infinity. For this next one, we don't have a square root, so we don't worry about that one. But we have a bunch of stuff in the bottom of the fraction, so we need to factor that. That factors to x plus 5, x minus 3. So we're going to say that can't be 0. So whatever makes these two things 0, we can't include, which is minus 5 and 3. So we're going to make our domain, we're going to skip minus 5. We're going to go from minus 5 to 3, and we're going to skip 3 and go on. So negative infinity to minus 5, union, minus 5 to 3, union, 3 to infinity. Okay, next we need to determine the slope of the line passing through the points negative 9, 4, and negative 1, negative 6. Our equation for slope is, which we'll call m, is y2 minus y1 over x2 minus x1. This is the kind of thing, if you don't know that, put it on your note card. Also, you might want to put some kind of thing to remember your two domain restrictions, because that might be pretty good to know. So I'll label these things. So I'll call this x1, y1, it's an x. We'll say this is x2, y2. So just plugging that in, minus 6 minus 4 over negative 1 minus negative 9. We have a minus minus, so that will become a plus 9. Minus 6 minus 4 is negative 10. And on the bottom, we get negative 1 plus 9, which will be 8. So this is our slope. We can actually reduce this a little bit. So minus 5 over 4. You can divide top and bottom by 2. They'll prefer it to be that way. But it's the same thing as minus 10 over 8. But I would try to simplify it if you can. If you can't figure that out, there's worse problems to figure. There's bigger things to worry about. But I would try and do that. Write an equation of the line in slope-intercept form. Fancy way of saying y equals mx plus b. That passes through the points 7, minus 3, and 4, 1. So the first thing I do is let's find our slope. Well, we just talked about our slope equation. It's y2 minus y1 over x2 minus x1, x1, y1, x2, y2. So it's going to be 1 minus negative 3 over, we'll say, sorry, I just lost my train of thought, 4 minus 7. If you do x1, if you do like y1 minus y2 over x1 minus x2, like if you switch the order of the y's and x's, that's fine as long as you do it for both. As long as like, if I circle these vertically, this is a pair of coordinates that match and this is a pair of coordinates that match. That's what matters. Which order it is, like which one you label x1, y1, x2, y2, doesn't matter. Okay, so 1 minus minus 3 becomes 1 plus 3, which is going to be 4. 4 minus 7 becomes minus 3. So our slope is negative 4/3, or 4 over negative 3. They're the same thing. So writing what we know, we have this. And we still need to figure out what b is. So the question is, well, how do you figure that out? Well, we have some information. We know an x and a y. So what we're going to do is we're going to plug in either coordinate. It doesn't matter which one. I'll plug in 4, 1. And now I've got to figure out what b is. And now I have a bunch of numbers. So minus 4 times 4 is going to be minus 16. So we're going to get 1 is going to equal minus 16 over 3 plus b. We're going to add that over. So 1 plus 16 over 3 equals b. 1 is the same thing as 3 over 3. 3 divided by 3 is 1. So we'll go ahead and we'll write it as 3 over 3 plus 16 over 3 equals b. And lastly, we get 19 over 3 is our b value. So we have our b value, we have our m. So our equation, I'll put it on the left side here. Y equals minus 4/3 x plus 19 over 3. Go ahead and circle it. Okay, I'm cleaning it up a little bit and moving on. Next we have 26, which is determine the average rate of change of the function 2x squared plus 2 on the following intervals. First is from 0 to 1. This one's a question that I've seen trip up a lot of people. The big thing here is when they see the word intervals, what that's telling you is those are telling you two x values. This is your first x and this is your second x. This isn't a point. Notice that these are brackets versus up here these points were parentheses. Like these don't like go together, right? So to find, we need an x1 and a y1, x2 and a y2. And we need those 2 points because average rate of change is just the slope between this x coordinate and the next. So between 0 and 1. So we need the y coordinates. Well, we know our first x coordinate is 0 and our second one is 1. To find the y coordinates, we just plug those into the equation. So to find the y1, what we're going to do is I'm going to say y1 is going to be 2 times 0 squared plus 2, which is just going to be 2. So our point, one of our points is 0, 2. And we're going to do the same thing for this other one. So to find y2, it's 2 times 1 squared plus 2. 1 squared is 1. 2 times 1 is 2. So it's 2 plus 2, which is 4. So this was going to be 1, 4. Lastly, to find average rate of change, we're just going to find the slope, which again is y2 minus y1 over x2 minus x1. So we're just going to find the slope between those 2 points. So it's going to be 4 minus 2 over 1 minus 0, which is 2, over 1, which is just 2 again. So that's the average rate of change between 0 and 1 of that function. Okay, let me erase some of this so I have some actual space to work again. Now we're going to do the same thing, but from 1 to 3. Well, I'll go in, again, x1, x2. So I need to figure out x1, y1, and x2, y2. Well, we already know our x's. It's 1, and it's 3. We actually already figured out what the y coordinate for 1 was, so I'm just going to jump to that from the previous one. If you want to see like how we did that, I mean, you plug in 1 of the function. You want to see me work it out. It's there. So 1, 4. For 3, we'll plug that in. So our y2 will be 2 times 3 squared plus 2. 3 squared is 9, so 2 times 9 plus 2, which that is 18 plus 2, which is 20. Now, once again, we got to take our slope, which I have the equation up there. I erased it a little bit. We need to find the slope between these 2 points. So 20 minus 4 over 3 minus 1. 20 minus 4 is 16. 3 minus 1 is 2. Our average rate of change, which is the slope between those 2 points, is 8. Oh, I don't know what that does. Okay, let me go and erase this. And we'll go on to the next one. Again, the big thing that people miss is they don't understand what I mean by interval. So, okay. Again, these are x1, x2. We already know our coordinate for the 0. We're going to have the coordinate 0, 2. The only way to figure out is our coordinate for -2. So, if I plug in -2 into that function, -2 squared is positive 4. So this is 2 times 4 plus 2, which is 8 plus 2, which is 10. So we have the coordinates 0, 2 and -2, 10. Sorry, an issue with the recording. Continuing on, we got to find the slope between these 2 points. So we'll do 10 minus 2 over -2 minus 0. We get 8 over -2, which is -4. So our average rate of change in this interval is -4. Okay, so now we need to write equation of a line in slope-intercept form. Slope-intercept form means, if I can write y equals mx plus b. We need to go through the point, actually use the highlighter for here. Go through the point 5, -4, and I'm gonna highlight this. Okay, I think there's a typo. Right here it says parallel, but right here it says perpendicular. Okay, no, sorry. I misread that. So first we need to find an equation of the slope and the form of a line that passes through 5, 4 and is parallel to the line x minus 2 is 7. Then I'll highlight second color for the second part. We need to write the equation again in slope-intercept form. It passes the same point, and now it's perpendicular to the line, same line. Okay, the first thing I want to do is I want to write this line. Seeing x minus 2y equals 7, for me, that doesn't tell me that much. It doesn't seem particularly clear what this line is doing. So I'm going to solve this. This is the same question both times, so I'm going to solve it for y. So I have x minus 2y, it's going to equal 7. Add the 2y to the other side. X equals 2y plus 7, subtract 7. X minus 7 is 2y. And finally divide by 2. When we divide by 2, we're going to divide the whole side by 2, but it's the same thing as dividing each of these individually by 2. So I'll say x over 2 minus 7 over 2 is equal to y. So that's the equation of my line. Here my slope is what's on my x, which I will say, which is 1/2. 1/2 times x is the same thing as x over 2, because 1 times x is just x. So to write an equation for this next part, I'm going to switch over to red for part 1, or yellow to be consistent. We need to write an equation that passes to that point 5, 4 is it parallel to the line. Parallel means they have the same slope. So that means my equation just getting started is going to be y is going to equal 1/2, because that's the slope originally, x plus b. And I need to figure out what b is. Well, how do I do that? Well, what other information am I given? The point 5, 4. So we'll plug that in for my x and my y, 5 and 4, and then we can solve for b. So 4 is going to equal 1/2, 5 times 5 plus b. Continuing on, we're going to have 4 equals 5 over 2 plus b. I'll subtract 5 over 2 equals b. 4 is the same thing as 8 over 2. You can imagine 4 as being 4 over 1. 4 divided by 1 is just 4. And we can multiply times 2 over 2 to get this common denominator. 2 divided by 2 is 1, so we're not changing the number. Because what we get is we get 8 over 2, which 8 divided by 2, again, it's 4. We haven't changed anything. We're just writing it so we can subtract the fractions. 8 over 2 minus 5 over 2, we're going to get 3 over 2. So our equation, that is for the parallel one, is going to be y equals 1/2 x plus 3/2. Now, up next for perpendicular. The trickiest part, I think, for a lot of students is figuring out what the slope is in the perpendicular line. Parallel is nice. The slope doesn't change. But for perpendicular, we do some kind of weird things. So we're going to take our slope. In this case, it's already a fraction. If it's not already a fraction, you can write it as a fraction. For example, if your slope was 3, it's the same thing as 3/1. What we're going to do with this fraction is I'm going to flip it over. So it's going to be 1/2. Sorry, I misspoke there. 2/1 when you flip it over. The bottom goes to the top, top goes to the bottom. And then I'm going to add a negative sign. Or I'm going to change the sign. If it was already negative, I'd make it positive. So that means my new slope for this new line is -2. And now I'm going to set it up. Y equals -2x plus b. How do I find b? Again, I'm going to use my points 5, 4. So it's a terrible y. 4 is going to equal -2 times 5 plus b. -2 times 5 is -10. I add the 10 over. We get 14 as b. So for the perpendicular line, it's going to be, I'll write it right next to the other one. Y equals -2x plus 14. And I'll just go ahead and circle those because those are my two answers. Okay, for this next part, we need to solve the system's equation using the substitution method. Oops, I missed some erasing a second ago. I'm going to try red this time. So the substitution method means that we need to solve for one variable and we'll plug into the other equation. We can solve for use either equation. I'm going to use this top one because x seems pretty easy to solve for. Solving this for x, I'll just subtract 3y to both sides. Now I have an equation for x. What I do with that, I'm going to plug that into my other equation. So this x equals, it's going to go into here. So we're going to have 3 times 5 minus 3y minus 2y equals -18. I can distribute my 3. 15 minus 9y minus 11y, 2y is going to equal -18. I can combine my y's together. So I'll get 15 minus 11y. That's where I was thinking that. Goes -18. Subtract 15 from both sides. I get -11y equals -33. Divide both sides by -11. You get y equals 3. Now that I know that, I can solve for x, which is going to be pretty easy because I have an equation for x. I have this one up here. So x is 5 minus 3. If y is times 3, because that's y, that's equal to 5 minus 9, which is equal to -4. So my solution is going to be -4, 3. If I wanted to check that, I could plug that into both of these. For the sake of time, I'll let you guys do that, but it should work for both of those. If you have an issue, then double check like your calculator or whatever. Okay, next we're going to solve this system using the elimination method. This is my personal favorite method to do stuff. So what I'm going to do is I have these two equations. I'm going to take one equation, I'm going to multiply it by something, and then I'm going to add them together so they cancel. So I'm going to multiply this times -2. And I'm going to rewrite it down here so we can like add it up easy. So -2 times 3x is going to be -6x. -2 times -7y is going to be plus 14y. And then -2 times 1 is going to just be -2. Now what I'm going to do is I'm going to take these two equations, these top two, and I'm going to add them together. I cannot draw a straight line to save my life. Oh my goodness. It's a bit better. We add them together, so I'm going to put this over there so I don't think to add this. 6x minus 6x is 0 x's. 5y plus 14y is going to be 19y. -17 minus 2 is going to be -19. And now I can just solve for y. Y is -1. Using that, I can plug -1 into either of these equations, and I can solve for x. So let's plug into the first equation. 3x minus 7 times negative 1 equals 1. Negative 7 times negative 1 is going to become plus 7, which means it's going to be 3x is going to equal negative 6. Divide both sides by 3. X is negative 2. Negative 2, comma negative 1 is our answer. Let me circle the other one too.
Okay, so number 30 says, the data in this table represent the enrollment at Y at a college X years since 2000. And then using the graphing calculator, we want to find the least squares regression line around in the near extent. So all you got to do is on your calculator hit stat and then go to 1 or edit. Then you can enter your X values in L1 and your Y values in L2. I've already done that though, but then you can hit stat again, then hit the right arrow to go to calc, and then go to number 4, linear regression. And then hit enter. And you'll get the equation formula with all the coefficients that you need. So I'll just write what the calculator gave me back. Y equals 369 point, we're rounding to the nearest tenth, so just 6 there. Plus 22110.7. Oh, can't forget X there, my bad. 3.69.6x plus 22110.7. Okay, correlation coefficient. Well, this in your calculator is R that your calculator should give you. And so R equals 0.9977, so to 4 decimal places. This is really close to 1, so this is a very good fit. It's a very good fit. Okay. Part C, predict the enrollment in 2022 if the linear trend continues. So X is the years since 2000. So 2022 would be 22 years since 2000. So X would be 22. So take 369.6 times 22 plus 22110.7. And I'm going to punch that in my calculator. And I got back 30,241.9. Okay. Well, there we go. That's all there is to that one. Do a little undo so you can see minus on the next part easier. Alright, now we have to solve the system of equations. So, I think the method I want to go ahead and firstly, there's a couple different methods you could use. But I think that we might get a little far if we go about the substitution method. You could also do elimination or anything though. What I'm going to do is I'm going to multiply the bottom side, right, by 2 on each side here. Multiply by 2, then I have 4xy plus 2y squared equals negative 10. Now I'm going to subtract it, or I said I was doing substitution. Let me not go back on that. Now I'm going to move this 2y squared over. So I'll have 4xy equals negative 2y squared minus 10. Well, 4xy is over here in this first equation, so we can substitute that in. So now we have negative 2y squared minus 10 plus 3y squared equals negative 9. Okay, cool. So we combine like terms with the y squareds, so that will just be y squared, because it's 3y squared minus 2y squared. And then I'll add 10 to the other side, so negative 9 plus 10 is 1. So y squared is 1. Well, this means y is plus or minus 1 if we take the square root. So it could be both. It could be just 1. What we might have to do is check positive and negative 1 and figure out what the different x values for each of them are. So I'm going to do that here on the left. So first let's try positive 1. So I'm just plugging in positive 1 for this. So then we'll have 4x plus 3, because that's 3 times 1 squared, equals negative 9. Well, if I solve, I have 4x equals negative 12. If I subtract 3, well then divide by 4, we have x equals negative 3. Fabulous. So this means we have a point negative 3, positive 1. I'll make a list over here, actually. Points. So here we have -3, +1. Okay. Let's go ahead see if we can plug that one into the next one, just to make sure. So we plug in -3 times 2 is -6 times 1. So that's -6 plus 1 is -5. So that checks out. Now let's plug in -1 and see what happens. So it will be 4 times x times -1, so -4x. Plus 3y squared, well, y is -1, so y squared is 1, so that's +3. Equals -9. Okay, and so then what does this equal? Well, let's take the 3 over, so we have -4x equals -12 divided by -4, and we have x equals 3. Okay, so if y is -1, then x is 3. So our 2 points, our solutions of our system, are firstly the point -3, 1, and then we have 3, -1. Basically, both of these points will solve this system of equations. Okay, use this system of equations to solve the following. Electronic sign for a grocery store is in the shape of a rectangle. Perimeter of the sign is 72 feet, and the area is 320 square feet. Find the length and the width. Well, I'm thinking that maybe your most useful things for, I'll write in blue so you can tell which one is this question. Most useful things for this is think about the relationship between length, width, and then area and perimeter. So area should be length times width, since it's a rectangle, so that would be 320, right? That's length times width. Now 2 times the length plus 2 times the width, that's your perimeter, right? Because we're just counting up the edge. That would be 72. Well, now all that's left to do is to solve for one of these, and then just plug it in. So I'll just divide this first equation by w, so we have L equals 320 over w. Then we can plug that in for L. So we have 320 over w plus 2w equals 72. So we simplify that, that'll be 640 over w plus 2w equals 72. Well, now what we could do is maybe multiply both sides by w. So we'd have 640 plus 2w squared equals 72w. Then we can move all this to one side and use the quadratic formula, I think. So go 2w squared minus 72w plus 640 equals 0. So use quadratic formula, that'll be -b, so negative 72, plus or minus the square root of -72 squared, minus 4a is 2, c 640, all over 2a, so, well, I hit the undo button, didn't I? All over 2a, so 2a would be 2 times 2, because a is 2, so. Okay, and I'm going to put that in my calculator. So that gives you that w equals 16 or w equals 20. But if you because of this, if w equals 16, then L has to equal 20. Because if we're following this equation over here to the left, this length times width is 320, and vice versa. So you can just say one is one of them. So we can say w is, whoops, I'm wanting to answer over there. I'll write my answer down here. W equals 20, L equals 16. The way I found out the other one is you just take 320, then you divide by W to get L. So 320 divided by 20, well, that's 16. Okay, 33. So we have this function, and we want to know how we could take f of x equals square root of x to give us this, 2 square root of x minus 5, all minus 3. So first thing we would do is, well, this minus 5, so let's do what's inside first. So shift right 3. sorry, shift right by 5. That's what this minus 5 does. Then there's going to be a vertical stretch of 2. And then we go down 3 because of that minus 3. And there we go. We've done it. That's all there is to it. So we just follow the order, saying on the inside it's minus 5, so we go to the right 5. Then we get stretched by 2 because of that 2 out there, and then we go down 3. Okay, so next we have this piecewise function, n of x, and we need to evaluate it for n of 0 and n of 2. Okay, well, let's think about n of 0. So let's first think about which function, there's 3 parts to it, which part do we want to use? Well, 0 is between -1 and 2, so I think we should use the middle part. So n of 0, for basically if your x, your input, is between -1 and 2, like 0 is, then we'll just use this one here. So n of 0, so n of x is x, so that would just be 0. Because we're just following equals x there. Okay. For x is greater than or equal to 2, though, it says negative x squared plus 4. Well, 2 falls into that bracket where it's greater than or equal to 2. So let's take negative 2 squared plus 4. Well, that would equal negative 4 plus 4 equals 0. So this also equals 0. Okay, so next we're continuing from what was on that last page. I have the function pulled up on another screen. I can't seem to get it to be on the same one, but n of negative 2. So here, the first condition says n of x equals negative 4 for if x is between negative 3 and negative 1. Well, negative 2 is between there, so this equals negative 4. So next, n of 5. Well, I think we go back to that condition where it says x is greater than or equal to 2. So then we would have negative 5 squared plus 4 is equal to negative 25 plus 4 equals negative 21. So there we go. Okay, so 35, we're looking for relative minima or relative maxima. So let's start with A. So I see 2 relative minima here, 2 parts where the graph just dips down, you see here. So by inspection, we can just look and see what those points are. So this one to the left looks like it's a negative 2, negative 4. Negative 2, negative 4. And this one to the right looks like it is 2, negative 4. And the maximum I'd say is right there. And it does a little dip back up, and that looks like it's at 0, 0. Okay, well, let's take a look at the next one. I don't see any relative minima here, but I do see a relative max, it looks like right there. Say negative 1, 2. Maybe note that these are relative. Yeah. And I'd say no relative minimum on this one, because the graph just keeps going down on either side forever. So it's not a relative minimum here. All right, so now let's think about number 36. It says, use interval notation to write the intervals where the function is increasing, decreasing, or constant. Well, let's first talk about where it's increasing. So it looks like there's an increase that happens on this graph between right here, and it keeps going up, right? So say for interval notation, say 2, infinity. Increasing. Now, what about decreasing? Well, let's just look where it's decreasing. Looks like it's going between negative 3 and negative 2 here. Constant, well, looks like it's between negative 2 and 2. Not so bad. All right, so now number 37, we have these 4 functions. These between, well, between these two functions that we're given, we have four sort of combinations of them, and we have to find what they are. So first we have f plus g of 3. Well, this would just be f of 3 plus g of 3. So it'd be, yeah, there we go. 2 times 3 plus 3 times 3 plus 1. So that should be 6 plus 9 plus 1, and that's 16. So this first one is 16. Now for b, we have g minus f of negative 2, so almost the same thing, except we're just going to be subtracting. I'm going to write that above there. So we will have, I'm going to write this in brackets so that we don't lose ourselves. 3 times negative 2 plus 1 minus 2, negative 2. Okay. Well, this is going to equal negative 6 plus 1 minus negative 4, so plus 4. So this would be negative 6 plus 1 plus 4, and that will be negative 1. Part C, f times g of 4. Well, that's going to be just f of 4 times g of 4. So we'll do 2 times 4 times, we're going to make sure to put all of g in parentheses. We're multiplying by the whole thing. All right, like that. So 2 times 4, that's 8. And we are multiplying by 3 times 4 is 12 plus 1. So 8 times 13, which is 104. Excuse me. All right, so for part D, it's f divided by g of negative 1. So we're going to take f of negative 1 divided by g of negative 1. So I'm going to write that above here again. So that will be 2 times negative 1 divided by g of negative 1. So 3 to negative 1 plus 1. Negative 2 over negative 3 plus 1. And that's just 1. So very cool. Okay, 38 says construct and simplify the difference quotient for the following functions. And then it gives us these. I'm actually going to maybe erase some of my work over here to the left to make some room. Oh, just give me one moment. There we go. Okay, I feel like writing in green now. Let's write in green. Okay, so A is 8x minus 5. Well, let's just use this difference quotient formula. I'm going to write way up to the left, top to the left, so I have less room. So f of x plus h, well, that will be 8x plus h instead of x minus 5. Then minus f of x. So minus f of x is 8x minus 5. Notice I have parentheses. Don't forget parentheses whenever you're subtracting whole functions. And divided by h. Okay. So let's simplify this. So this will be 8x plus 8h minus 5 minus 8x plus 5 all over h. Okay. Well, I noticed that these will go away. The 8x's will cancel with each other. Maybe I'll write in red so you can see. 8x's cancel with each other. We have minus 5 and plus 5. So then all we're left with is 8h over h. Well, those h's should cancel. We're just left with 8. Okay, cool. I'm going to work this next one in blue again. Okay, so 3x squared minus 5x plus 4. Well, let's just plug it all in. So 3 squared minus 5 plus 4. Okay, now minus f of x. 3x squared minus 5x plus 4. over h. Okay. Okay, cool. So now we're ready to do some simplifying. So I'm gonna maybe simplify this top row first. I'm gonna do it right over here below number 36. So this should be, oh, what did I do? So 3 times x squared plus 2xh plus h squared. If you just do the whole FOIL thing, minus 5x minus 5h plus 4. I'm running out of room, aren't I? Minus 3x squared plus 5x minus 4 all over h. So I'll write that out all over. We'll distribute that 3, so 3x squared plus 6xh plus 3h squared minus 5x minus 5h plus 4 minus 3x squared plus 5x minus 4. Divide by h. Alright, now we can combine like terms, so I see that these 3x squareds should knock each other out there. And we have plus 5x and minus 5x, so those can go away. Is there anything else here? There's plus 4 minus 4. Okay, so now what we're left with over here is 6xh plus 3h squared minus 5h over h. So yep, that should cancel those h's. That h squared though, it'll keep an h there, so 6x plus 3h minus 5. Okay, cool. So that should be the answer for this one. Excellent. Okay, so for number 39, we're given these two functions, and we want to find the compositions f composed of g, and then g composed of f. So let's take f composed of g. So that what f composed of g means, again, let's write in black this time. F composed of g means that you're going to take f, and you're going to plug g of x in there for x. So that's what f composed of g is. Okay, well, let's do that. So we have f is x squared minus 4x. So we're going to take this g of x, this 2x plus 3, and plug that into f. So 2x plus 3 squared minus 4, 2x plus 3. Excellent. Okay, so let's simplify it now. So if we FOIL that, 2x plus 3 squared should be 4x squared plus 12x plus 9, I think. Then minus 8x minus 12. So let's simplify that. So that will be 4x squared. 12x minus 8x, well, that should be 4x. 9 minus 12, and that will be negative 3. And that should be f composed of g of x. Right there. Okay, let's do the same thing, but for g composed of f. So this time we're taking g and we're plugging f in. I'm going to write it up top. So 2, Apple Pencil always does this. So 2, x squared minus 4x, and plus 3. Then what do we get? Well, that will be 2x squared minus 8x plus 3. Okay, and there we go. That should be g composed of f. So I'm going to write both of those over here so you can see them more easier, maybe. La-di-da-di-da, 4x squared plus 4x minus 3, and g composed of f, we said that was 2x squared minus 8x plus 3. Okay, excellent. So number 40 says, write a variation model using k as the constant of variation for each of the following. A is the volume of a rectangular solid varies jointly as the length L and the width W of the solid. Next is the time of travel T is inversely proportional to the travel rate R, or the rate of travel R, and the circumference C of a circle varies directly as its radius R. So first part A, it says volume varies jointly with the length and width. So it's a rectangular solid, so the volume varying jointly with the length and width, well, that should be V equals K times L times W. And this is because we're saying the length and width vary. If the volume varies jointly with length and width, this means that it varies with both of them at the same time. So both of them being multiplied. All right, time of travel T is inversely proportional to the rate of travel R. Well, inversely proportional means that as one gets big, the other one gets smaller. So maybe a way that you could think about this is K over R. Because now as R gets bigger, T is getting smaller, and it has to do with this constant K. Okay, so now the circumference C of a circle varies directly as its radius R. Well, C is KR. That just means as R changes, since it's direct, there's no modification we have to make here. So just as R varies, the circumference also varies, but we have this constant here to tell us how it varies exactly. Okay, so 41 says, the area of a picture projected on a wall varies directly as the square of the distance from the projector to the wall. So if a 15-foot distance produces a 36 square foot picture, what is the area of the picture when the projection unit is moved a distance of 25 feet from the wall? Okay, so it varies directly as the distance, so let me just write an equation we can write here. Maybe we can say A, the area, is a square of the distance, so d squared, and it varies directly, so times k. Okay, so let's use this first bit of information, 15-foot distance, 36 square foot picture, so that would be 36 equals 15 squared times k. Okay, well, we can use our calculator to solve that. So we get 36 equals 225 k. Then we can just say k equals 36 over 225. Well, that tells us what k is. So what's the area when the projection unit is 25 feet from the wall? Well, that would be, following our formula here, A would be 25 squared times 36 over 225. So I'm going to plug that in my calculator. We end up getting 100. Say 100 feet squared. Whoops. There we go. 100 square feet. Okay, so what we did is we took one piece of information to find k, and then since we had k, we had everything else we need to find the area. If the projected image is 144 square feet, how far is the projector from the wall? Oh, excuse me. So we're kind of going backwards this time. So we have the area is 144 equals d squared times k, which is the same. It's going to be 36 over 225. So we can multiply both sides by the reciprocal of this fraction here to algebra it away. And that gives us that d squared is 900. So the square root of 900 should be 30. So there we go. D is 30. I guess I'll write answer like this. equals 30. Notice you would get plus or minus square root here whenever you square root 900, you get plus or minus. But minus would be minus 30. And in the context of this problem, that doesn't really make sense. That would mean that the projector is on the opposite side of the wall, which I guess makes sense, but I think it just wants the positive one here. All right, number 42, we're using variation model again, and the problem seems almost the same. It says stopping distance of a car varies directly as the square of the speed of the car. If a car traveling 50 miles per hour has a stopping distance of 170 feet, find the stopping distance of a car that is traveling 70 miles per hour and round to the nearest tenth of a foot. Okay. So first, a car traveling 50 miles per hour, stopping distance of 170 feet. Or, I guess first let's think, stopping distance of a car varies directly as square of the speed of the car. Let's call stopping distance D. Varies directly as the square of the speed of the car. We'll write speed as s squared times k. Okay, so that is our variation model. Now we gotta use this model to solve this. The one thing I would say you really have to be careful for, though, is it says that the speed is in miles per hour. Then the stopping distance is in feet. So we're going to have to do some sort of unit conversion here. You could either convert the feet to miles or the miles per hour to something like feet per hour. Let's go ahead and do miles per hour to feet per hour just because I feel like that. So 1 mile, right, I think is 5,280 feet, so 50 miles, 1 hour, times 5,280 feet, 1 mile. And our units of miles will go away, so 50 times 5,280. That would be 50 miles per hour is 264,000 feet per hour. Okay, we can do a similar conversion for 70 miles per hour. I'll go ahead and do that. Again, looks like we're just multiplying by 5,280. I just remember that that's the amount of feet in a mile because it's 5 tomato. I think that's a little funny. Anyway, 70 miles per hour is 369,600 feet per hour. Okay, so now that we're all in the same unit of feet and we want feet back, I think we're ready to do this. So these are information. So the car has a stopping distance of 170 feet, so 170 equals 50 miles per hour. So we're going to convert to our feet per hour thing that we just found. Squared times k. Okay, and this number should be absolutely gigantic. So 170 divided by 264,000, and that's squared, right? Yeah. Okay, and yes, so we get 170 equals 6.9696 times 10 to the 10. Okay, and then if we solve, we will have 2.439164371 times 10 to the negative 9. So absolutely tiny numbers here, but here's k. Here we go. Okay. So we want the distance for a car that is traveling 70 miles per hour. So what we'll go ahead and do is we'll say D equals then our 70 miles per hour is that conversion we just did, so 369,600 squared and times k. And we already found our k. Whoops. So our k is going to be, I'm just going to write it this way, 170 over 264,000 squared. Okay, so now we're going to plug that in the calculator. And that gives us back 333.2. And that's in unit of feet, so we don't need to do any more conversion. So here will be 33.2 feet. There we go. Okay, so most of the problem there was just converting, making sure we're in the same units. 43 says, given this function, find each of the following. First, he's completing the square to write the function in vertex form. State if the parabola opens up or opens down. Identify the vertex. State if the function has a maximum or minimum. Give the value and state the domain and range. Okay, so let's get started completing the square. I'm going to erase some work over to the left again. Oh, I guess I can't. Cool. Oh, I can erase that though. Yeah, let's erase this. We'll just need some more room. Okay, so completing square, write it in vertex form. So I'm going to write this over here. Okay, so for completing the square, first thing I think is, let's factor out the 2 first from this function. So x squared minus 2x minus 3 over 2. Okay, so far so good. So now we have to think what perfect square trinomial has this at the beginning, has this x squared minus 2x. Well, the answer should be x minus 1 squared. Because if you square x minus 1 squared, you get x squared minus 2x plus 1. Notice the only thing different here, though, is this. We have negative 3 over 2. Instead, x minus 1 squared is plus 1. So let's think about how much do we have to subtract. So if we take away 1 and then 3 over 2 more, so that would be 2 over 2 and then 3 over 2, so minus 5 over 2. Yeah, so x squared minus 2x plus 1, and then minus 5 over 2. And that should give us this x squared minus 2x minus 3 over 2. And don't forget, outside of all of this is 2. So let's multiply the 2 back in, and we have 2x minus 1 squared minus 5. And that is the same function. So here we go. That's it in vertex form. So I'll write 2x minus 1 squared minus 5. Okay, so what's next? State if the parabola opens up or down. Well, in front of that 2 in front of x squared, it's positive, so I'd say that this one opens up. Identify the vertex. Well, we already wrote it in vertex form. So remember, vertex form would be the h and k. So x minus h on the inside, and then plus k at the end. So minus h, so we are subtracting 1. So first point should be 1. Then plus k, well, plus negative 5 at the end. So our vertex should be 1, negative 5. Based on that. Okay, so state the function has a maximum or minimum and give that value. Well, since it opens up, the vertex should be the minimum. So our minimum should be negative 5. And negative 5. And no maximum, right? Because it just keeps going up. If you imagine the parabola opening up. State the domain and range. Well, it's a parabola, so our domain should be all real numbers. There's not a number that you can plug in here that makes the function not work anymore. Any value of x is okay. There's no way we can divide by 0 or get the negative square root of a number or something like that would make a problem. Now what about the range? Well, we know the minimum, and we know there's no maximum, so we know it keeps going, so our range, I'd say, is -5 to infinity. With -5 should be in the square bracket here. Included. Okay. Next, find the vertex of the function f of x is 4x squared minus 24x plus 11 using the vertex formula. So the vertex formula, if we want to find the x value of our vertex, if we have, a x squared plus bx plus c, the x value should be negative b over 2a. Would be the vertex. Or I guess, say h sometimes. But x value of the vertex. So b in this case is 24, so negative 24, sorry. So b, negative 24, that's positive 24. Over 2a is 8. A is 4. 2 times 4 is 8. So 24 divided by 8, that's 3. So that should be the x value of our vertex. So let's plug in 3. So we have 3 squared minus 24 times 3 plus 11. So that'd be 4 times 9 minus 24 times 3, that's 72. Plus 11. So I'm going to put that in my calculator. Alright, and that would be negative 25. So our x value is 3 and our y value is negative 25. So here we go. 3, negative 25. Awesome. And there's the math review.